ACA has been great in the educational portion, and they set up this program to try to continue that education value that they provide. So this is just another small segment of trying to extend their education to our members. It is a pleasure to introduce two well-known experts in the specialty of building or renovating a USP 797, 795, and USP 800 compliant sterile rooms or non-sterile compounding rooms as it relates to the design and the engineering. Each will approach this information from a different perspective. Now I want to introduce Bob Falcom, who's with Gates Healthcare Associates, who's been doing clean rooms for multiple years.
About 100.
Prince, who a lot of you know, that's been around and been generous to provide education and to give the members more information about what it takes to open these rooms. And this is the one part that I know for sure it's becomes a surprise to a lot of people building new clean rooms as well as renovating it, because the real high money is in the upper ceiling portion, and that's where the engineering comes in. So these folks are here to answer some of the questions and try to give you some ideas and what to look for. Brian Prince is going to start off with his, he's got a slide presentation that would be helpful.
All right, awesome. I appreciate that. Let me start this slideshow. There we go. So thanks for the introduction and letting me be a part of the group today. My name is Brian Prince. I'm a compounding workflow and lab design consultant. I have designed and or consulted for more than 200 compounding pharmacies. Pretty much most of those have been 503As, a couple of 503Bs, still relatively new in those 503Bs, not integrating into the market yet. Maybe some cosmeceutical and nutraceutical type stuff. But where I really hang my hat in this is on the engineering side and really with the calculations. I design the labs. I design all of the air handling systems. I'm not a mechanical engineer, but what I do is I walk the architects, the engineers, the general contractors, the electricians, the plumbers, anybody that's involved in the process of a lab design, I walk them through that. So really I am a quasi-project manager, or what we call owner's representative in the construction side of this thing as you're building out a new space to be USP compliant. The way that I got started in this business is back in 2013, I was in a compounding pharmacy, didn't even really know what a compounding pharmacy was. And there were probably 6 what we know as powder hoods or BSC1s or CVEs or whatever you want to call them. And yet there was still powder resident when I knew that nobody was open bench compounding. And so that started me down a path where I actually wrote an article for the IJPC, got published. It went to a second article, conference speaks. I've spoken for the American College of Apothecaries for many years. I think probably as early as 2014 when we were in Baltimore back then. And every other organization you can think of. And so you can see throughout my adventures here, I continue to see the same things over and over, which is really what we call powder handling faux pas. So if you are heavy into the non-sterile space, I would challenge you to go around and actually look. And actually there's a new 483, FDA 483 write-up for a company where they actually, the FDA saw blue trace powder. And I think that's probably the sildenafil or whatever that is. They chased it all over the facility, right? So now the FDA is starting to get wise to these things that I've been looking at since 2013. And if you've ever seen me speak in conferences, you know that I like to carry my flashlight around, and I'm really kind of the rogue safety guy. And then that started me down a path of being an independent consultant around 2015. And so that's really where I started. And I like to dissect what are these engineering controls. And so this table too comes out of USP 800. And it talks about the CPECs and the CSECs and really just kind of give fancy acronyms to these things.
I'm gonna think, what does it say?
Let me just pause for a second and say, hey, I know this. Let this be an open forum. It's kind of like I also speak for the ACHC at all their PCAB USP 800 workshops, and it's a very interactive type thing. I can talk for an hour about nothing. So if you have questions, just kind of like, hey, I have a question. Can we talk about that? I think that's okay, unless you want to hold the questions till the end, which is acceptable as well. But what I like to do is show folks that per USP 800, and this is table 2 for non-sterile hazardous. Table 3 looks very similar to this as well when it talks about externally venting. Externally venting. What does that actually mean? What that really means is that we're going to send perfectly good air out of the building. This is a utility set exhaust blower. And so I'm sending out that clean room air at, let's just say, 68 to 70 degrees. And this happens to be down in the South where I live. I don't know if you can tell by the accent. So I'm sending out some wonderful air conditioned air from my hazardous drug clean room, from my hazardous drug non-sterile room where I'm doing hormones or tretinoin or methimazole. But here's the takeaways. If you throw perfectly good air out of the building, you then got to put air back into the building. Air is a 1-to-1 ratio. And if you haven't integrated USP 800 compliance yet, there is nothing about your existing air handling system that was ever meant to do that much external exhaust air with fresh. So they call me Bad News Brian at PCAB during the workshops because I get to tell you the bad news. If you throw the air out, you got to put the air back in, and that system right there starts at a minimum of $30,000. It goes up to $40,000 and $50,000 depending on how much air you're actually having to put in the space. The more air you exhaust out, the more air you've got to make up to put right back in it. So this system is then actually conditioning all of that outside air to put it into your clean rooms at, say, 64 degrees. Because by the time you put technicians in rear tying gowns, double shoe covers, double gloves, hair bouffant, and mask, they want it pretty cool in there. And so that takes a dedicated makeup air unit. There's nothing about an existing HVAC system on your commercial facility that was ever meant to do this. So there's no easy pass here, right? It is expensive. These are what I call the unintended consequences of USP 800. I don't know if the expert committee really thought through what this is going to mean, but what this also translates to is another $500 a month on your electricity bill. So not only did you drop $30,000 to $50,000 on the makeup air unit, but now every month you're spending another $500 in electricity because you're pumping, again, perfectly good air out of the building. That's what it says. The CSEC, the lab room must be externally vented. The translation is, without it explicitly stating, is that there's no opportunity from air that has been supplied into a hazardous drug space to be recirculated back into the air handling system. It is what we call a one-pass air. That is the intent of the chapter, even though it does not explicitly state it as one-pass air or no recirculation. That's what they mean by externally exhaust. Here's two perfect examples. So if you're going to start a construction project in the near future, whether you're non-sterile, sterile, this is a perfect model. Take your phone out, take a screenshot, snippet, whatever it is, and show this to your HVAC contractor and your mechanical engineers. So let's talk first about the non-sterile example. In this situation, I'm actually doing the allowed redundant HEPA filtration. If you don't know what that is, inside of our powder hoods, if it's got two HEPA filters of equal capture value, then it is a redundant and it can be safely recirculated back into the room. I like room neutral hoods because these are not externally exhausted. They are what we call room neutral. They do not contribute to the negative pressure and they do not contribute to the air changes per hour in this non-sterile situation. So I'm using a low wall exhaust so that I can sweep the air and balance this space. Now, many years ago, I used to be in the engineer containment business, and that's a fancy name for hoods is really what that is. And I can tell you, the more hoods you start connecting externally to an exhaust system, the more of a Rubik's Cube it becomes. So USP 797 used to have a parameter of 3/100ths of a decimal to 0.02 to 0.05 positive. They've now done away with the top end of that positive, which is great. However, if we look at USP 800, they've given us a negative pressure gradient of negative 0.01 to negative 0.03. That is 2/100ths of a decimal place. And again, I don't know who on the expert committee thought that that was a good place to land a negative pressure room, but I can tell you it is a hard place to land a negative pressure room without fluctuations, without getting too much into the barometric pressures and the envelopes and the whole, utility sponge, which is a clean room based on physics. Understand that that's a very tight gradient. So the more hoods you connect to that Rubik's Cube, the more difficult it's going to be for you to balance that negative pressure space. So I like to use low wall exhausts because this is a easy way to balance a space one time instead of juggling all these hoods. And I'm speaking specifically about non-sterile right now. Now, with that being said, if your state board, and let's say you're Oklahoma or you're Nebraska or you're wherever, your state board is probably not going to understand. I'm going to back up one slide. They probably do not understand what is meant by Externally vented preferred, they know that as a trunk, or redundant HEPA filtered in series. That means I can recirculate. Again, the chapter doesn't explicitly state you're able to recirculate, but that's the implied meaning. If you're using redundant HEPA in series, you can safely recirculate. So they may walk in and you may have invested $10,000 in that redundant HEPA filtered hood. It's recirculating, it's neutral to the space. And they go, where's your trunk? Where's your trunk? And then you're going to have to actually coach them. And I've actually had this conversation with lots of my pharmacy clients. Say, hey, can you get on the phone with a state board inspector? Because they don't understand how to dissect table 2 for non-sterile compounding. And I get it, because nobody, the BPP, NABP, nobody's out training the state board inspectors on how to interpret USP 800 tables 2 and tables 3 and all the other kind of engineering controls that go along with that. Now let's jump over to sterile real fast. Okay, let me just pause for just a second and ask, does anybody have questions? I feel like I talk kind of fast, but we've got a limited amount of time. But are any questions from the audience that anybody wants to throw out there?
I would like to make a follow-up comment on that if I could.
Yeah, please do.
I really agree with, very much agree that you should use double HEPA filtered units. One little thing that wasn't mentioned that can come up, if you want to expand, the HVAC system that you have on the roof are good for a certain amount of air. And all of a sudden you want to add on 3 more hoods, is a number. Well, if they are redundant, you probably can. If you are venting them, you're going to need a new HVAC system. So that's another, just a little thing that's I'm going to throw in. That's all.
And let me just give you further interpretation. I keep a 3D construction model because I teach a lot of contractors on how to build compliant spaces. So this is a single HEPA hood. Again, this is a non-sterile room. This is a single HEPA hood that is externally connected. So you have to have that trunk. And this is probably what the state board is going to be looking for, is this trunk line connection. What they don't understand is that if it is a redundant HEPA, I don't need that trunk line. It can actually recirculate back into the space. Bob nailed it, is if you're thinking about the scalability of your business, because the business model drives your design first. And I have this conversation every day with new clients. I don't care that you've got a 20 by 20 space. Tell me your business model. Let's back into this equation. Now let's look at the past 5 years of business trending, and let's pull out our magic crystal ball and let's talk about the next 5 years of business trending. Because if you think, well, right now I've got 2 powder hoods, but I'm growing fast enough that I could foresee in a 5-year scope that I may need 2 more powder hoods and 2 more technicians, then you need to start thinking about the space and the airflow requirements. And that's more especially true on the sterile side, because right now you've got 1 biological safety cabinet. But right now it's kind of like, man, we're doing a lot of testosterone injectables. We're doing a lot of cyclosporin. We're doing a lot of tacrolimus. Those things that are on the hazardous side. I really feel like if I bring on a couple more vet providers, I'm going to continue to grow that business. I may need a second biological safety cabinet. At 450 CFM going out of the building, if this air handler was not built specifically to add another one, I can't add another one, right? Because now there's not enough juice for me to add another hood that's going to pump another 450 CFM out of the building. So Bob made a stellar point. You've got to think about scale, right? Maybe you'll always be in 1 biological safety cabinet, but if you ever think there's going to be 2 or 3 in the scale, you need to absolutely consider that during the design and construction phase. Here is a wrong interpretation of USP 800. Notice I'm spending a lot of time on 800. We spend a lot of time with 797. I just like 800 because I feel like there's the most subjectivity to the whole process is really inside of 800, because it doesn't give us a supplemental construction document. For that matter, USP 797 doesn't give us a supplemental chapter on construction specifications. So there's a lot of interpretation that goes into this. But I actually saw this. I drew this because I actually saw this out in the field. The particular non-sterile compounder had a powder hood, single HEPA, that was sending air out of the building. But yet they had a low wall return that was then recirculating air. So notice what's happening. I got air that comes in that partially goes out and partially gets recirculated. And remember what I told you, the interpretation that the C-sec, the room, should have 1 pass air. You should not recirculate air that's been introduced into a hazardous drug room back into the air handler. So once I saw that out in the field, I realized that our local HVAC people, our local engineers, they don't truly understand this thing that we walk in called USP. And that's why I spend a lot of time dissecting this, because engineers and architects are wonderful people. I wish I had multiple softball teams on the weekend with these guys, but they'll say, well, we do a lot of chiropractor offices. We do a lot of dentist offices. We've done an outpatient facility. We've done, an oncology center. They've done all these wonderful things. But the reality is they don't live inside of these USP 797, 795, and 800 documents like we do. So therefore, their interpretations are going to be a lot different than our interpretations as well. So we have to be careful when we're vetting out some of these folks, because you can't handhold them as much as you need to handhold them. You absolutely can't handhold them. And so let's talk briefly about USP 797 and 800. There is an intertwinedness, but USP 797 says that HEPA filtered air must be introduced at the ceiling. And then there is this preference for these low wall, what they call returns in 797. We call them exhausts in 800, depending on if they're recirculating or not. And they put them low to the floor, about 6 to 10 inches above the finished floor. Now, air takes the path of least resistance. So the goal is to sweep out the space to get good dilution. And in a future state, and Bob can probably talk about this as it relates to smoke studies, in a future state, more state boards are going to ask to see the videos of our smoke studies, making sure that we're getting good dilution into those clean rooms so that they know that there's no stagnant areas, right? Therefore, you need to be testing for more CFUs, or that's where you're growing CFUs on the plates, right? So there is a carve out that says if you put the return on the ceiling, you've got to prove it with a smoke study. And let me be the first to tell you, you'll never, ever prove a smoke study if your returns are located on the ceiling. So this design goal of sweeping air is specifically called out in 797. It is applicable to USP 800 sterile. And I would even tell you that this is a good design practice for USP 800 non-sterile hazardous as well. So you're handling a lot of hormones, you're handling a lot of, tretinoin, and those things that the NIOSH hazardous drug list have deemed that they are hazardous. So the goal is that when those technicians bring their gloves out, and that's why you saw my finger with the powder on those earlier slides, that's because our wonderful technicians will not keep their hands inside the hoods while they're doing the formulation, right? They got to come out and they got to tap to the keyboard, or they got to interact with the mouse, or they got to get the tamper, they got to get another piece of glassware. So if they do come out, if we do aerosolize micron-sized powders and we are sweeping air from the ceiling to the floor in a non-sterile situation, then maybe we can statically charge that powder to the floor. And then what are we doing every single day in our rooms? We're cleaning the floors, right? At least I hope you're cleaning the floors every single day at the end of the shift. So this is just a really good design goal to keep in mind. And I could get into materials of construction, but I'll tell you what, I'm going to let Bob get into materials of construction. And I think that was pretty much, that was the last slide. So I'm going to stop sharing unless anybody has questions before we give it to Bob to talk about other things. Any questions about engineering controls? All right, I'm going to stop sharing. There you go, Bob, it's all you.
Well, put that slide back on in for me, please. When you do, just the very last one.
Yep, stand by.
Well, don't.
No,
don't.
Yeah, I'm not real fast. There we go.
As you can see in the drawing, that is a very, very good example of a clean room, of a sterile suite. It could be certainly used as a non-sterile suite, and it can also be used as an 800. But what I am looking at, which is very important, is going from the floor up. You'll notice that there's a clothes strip. That's for the purpose of cleaning. I would almost always recommend that you use nothing but vinyl welded floors. There is an epoxy floor that people like. It breaks down.
Yep.
And so I would suggest that is a perfect example of what you need and must have in the floor. There's no cracks, there's no crevices, and you're going to get maybe 5-6 years out of it. You may have to redo it, but that's a great floor. Now, looking straight up, the next thing, which I think is kind of buried, is that you do need returns low, as we talked about it. The actual thing I'm going to say with the return low is it should be placed in such a way that you can get this unidirectional flow, even though it's jagged, and have it sweep away, hopefully from the hoods and so forth, out and come back. There's the reason for the 6 inches. You leave 6 inches off the floor for cleaning. There's another thing that is rather important to me that's rarely said. You also do not want to exceed 30 inches above the floor. The reason for that is the airflow uniformity. You want to have dirt be below work surface high, all this disturbance. So you have to design a certain speed from 6 inches up to 30 inches up, and then make the grills appropriate. The windows that you see next, you'll notice there's no sills. They're as flush as possible can be for the inside of the room. Incredibly important. Cleaning. The walls themselves, this happens to be a clean room partitioning system. And you'll see that there is relatively no jagged edges and so forth in the room. They're using batten strips, the horizontal batten strips, to be also electrical panels. And again, it gives you a very good opportunity not to have contamination. When you get to the ceiling, that is what's called a 2-inch T-bar. If you walk into any industrial building, you're going to see 3/4 inch T-bar, a very thin T-bar, which is very, very, you just can't seal it. And so this is a much wider T-bar. I believe that this, oh, thank you. And there's a return, by the way. There is discussion on that return, if or if not, there should be filtration in it. I'm going to make a statement that it should not be filtered because the condition of the room, this is now sterile, the condition of the room exceed what one of those type of filters can handle. They're called MERS 6 filters, which is, you see them in commercial use. The air quality exceeds that, and most anything will pass through it. When you take that grill off to replace a filter, you're doing horrible things to your room. You want to really have an environment that is always clean. You want to limit the people in it. So why rip something out of the floor, out down there? The second part about that is the ceiling. If you are designing materials above the ceiling, get them away from the clean room. You have an HVAC system has water in it. So that if you're going to want to work on it, you want to repair it, you want to repair it away from inside the room. You don't want to have somebody climbing on the ceiling. There you go. And so I strongly suggest, as you see here, move it away far enough that it doesn't interfere with the inside of that shell. It's sacred. Now back to the ceiling. You can leave it the way it is.
Okay.
This is not a grid system. This is actually a support system. The purpose of it is putting in uniform, very strong grid that doesn't move because it'll leak. You're either positive pressure or you're negative pressure, but you just want to avoid that as much as possible. The ceiling tiles themselves should be vinyl coated and seamless. You'll notice that these are very strong turnbuckles and so forth to walk on it. Again, you don't walk on it, but the point is, it works. I see here this thing is gypsum vinyl board, 16 pounds.
Yep.
One time, I mean, this wasn't sterile that I'm talking about. Actually, it was IBM to be both. And we were in a clean room. We popped a tile, and a brick fell out. And the purpose of that brick was to keep the tile in place. So you notice it's a heavy vinyl T-bar, or heavy vinyl tile. That's very important. Again, you're looking for uniformity in the ceiling. You see the air coming in, and it's going to what looks like a caboose. And that is what's called a fan filter module. It is one way of introducing, and probably the most common way of introducing air into the clean room. And it is a HEPA filtered unit, 99.99% pure at a certain size micron. And excuse me, there is a motorized control on it that allows you to ramp it up, ramp it down, and gives you some sort of an adjustable variable speed. That control, which just looks like a fan speed, should not be on that machine the way it comes. It should be, again, remote. On the bottom, I am seeing a number of, one is a test port we'll talk about that a little bit later. The other is a fire sprinkler, and the fire sprinklers should be flush, as you can see. Mm-hmm. Now, you see this very handy little caulking gun. Many states demand it, not require it, demand it. to make an airtight seal. Now you've already got gasket in there, and if you do, that at least allows you a dam. Do not use silicone. Use a urethane based product. The silicone is what messed up the first space shuttle that went out, that telescope. The over to the left is no, that's the bottom of the HEPA filter. What? Oh, and then of course, please use clean room lights. They are this grid. You should use nothing less than a 1.5 inch wide grid, which this is even more so as a 2-inch grid. It's wide, nothing fits into it, but a regular light, a troffer light, leaks like a sieve. And so these are specially sized lights that are as much as possible airtight. So what's left here?
I'll go back to the model. And Bob, I just want to apologize. Earlier, I thought I was sharing my screen of the PowerPoint, and evidently I was not. The screen was lit up, but evidently I didn't actually hit the share button. So I apologize earlier that you were looking at the wrong pictures. But
yeah. No, we weren't. It worked.
Okay. Yep. So yeah, there's a lot going on here. There's clamps that you could talk about, clamping from above versus caulking. And so there are certain states like Texas, it doesn't matter. They want to see every tile caulked. And I can tell you, I've seen jobs where like a 3rd grader was in there with a caulking gun and it looked terrible.
Oh, yes.
So I'm not a huge fan of the caulking, but again, some state boards don't want you to, because they can't see the clamps. They'd have to go around with the broom handle, start popping up tiles. But clamps to me work better than caulking, but personal opinion.
I do. Well, I don't disagree with that, but again, it's there's enough states that do that. What do you find out from your local state? One thing, if you do use the clamps, don't forget to leave one open, or you'll never get up there. Kind of a little thing that I ran into. Okay, so we have this environment in which you're going to put hoods, and there are all sorts of descriptions for them depending on the layer of cleanliness you need. But all rooms have a certain amount of what's called ISO air requirements, air cleanliness. The the minimum that you have would be a clean room or anything that has nothing to do with hazardous, and that's a USP 800 room. Basically, that they have it's changed to excuse me, I'm trying to think of the word, but this was the original numbers that were in US. But basically what it means is you have 100,000 particles or less in the room, which is probably what you find in a hospital surgical suite. The next level is a USP ISO 7, which is 10,000 particles. So you can see that's quite a jump. That is in all of the sterile, all of the buffer rooms, and their purpose is to protect the hood, which is ISO 5, which is less than 100 particles. But they've also added a velocity requirement that the air has to be uniform. So that's really the ideal sterile thing. These have to be tested, and no less than once every 6 months, a certification company will come in and look for the pressures of the room. We didn't talk about that, and we need to. The pressures of the room, air quality, velocities, and as was mentioned, smoke tests. They're looking for a really clean room. And the other thing that is called viable testing, which is you're looking for bacteria and fungus. These things can get you, and frequently do. And so by doing all of the things that we're just showing you here, eliminates most of the probabilities of the room. Oh, like that was a good one. Or does not, but what it does not do is remove the probability of humans in the room. But a room can kill you. And we had an example, Gates had an example of one which was supposedly built properly with returns and stuff. And must you? That's terrible. Anyway, they had what was unknown is that in the ceiling they had cut open some areas and left a return to pull air from above the room. They were down for 6 months. The place was loaded with fungus. it really can get you, and it does get you. And it was the thank you, New England compounding, for making the world aware that you can really have a mess. So I just, it's so important to do this way. There is no options but to spend some decent money on it. Any questions? No
Surely
questions?
somebody actually, let's see what's in the chat.
I'm sorry?
Yes.
Yeah. Go ahead.
No, I wasn't. I was, I'm sort of out of words.
Bob, could you just express some of the problems from boards of pharmacy that you run into with the clean rooms? What's the major ones that we have to deal with?
We've been all over the country, and I think between Brian and myself, we've probably done, well, hundreds of clean rooms. But you know, my background was HEPA filtration in the beginning, and then I moved into pharmaceutical. Then I started building them, and now I've become a certified tester on the rooms, and in retirement, design, build, and or trying to find fungus and bacteria. The primary problem is going to be people. It's and you're going to have, when you do these certification testing, some issues. The goal is to keep them under allowable limits. But the biggest thing, I think myself, is the sealing. You've got to keep stuff out of the ceiling. You've got to prevent breaking that barrier that you've spent the last 6 months keeping clean. And in doing so, you're going to save yourself a lot of problems. When you buy HEPA filters for your rooms, there's a number of choices, but as far as pharmaceutical is concerned, which this goes into the pharmacies as well, is there's either one which you dispose of in its entirety, which also implies that you're taking a 2x4 foot can out of that clean room. I think what you're doing. But they do come with room size replaceable filters where the can stays in place. Not a bad idea to do that. But most of it is just plain slopping it in. Those pictures you saw, that's very common. You also, 80% of the market was electronic and 20% was pharmaceutical. Electronic doesn't care about the fine particles that we do. We know for a fact that if you do create an ISO 7 condition and you do have a good 99.97% HEPA filter, it's going to stop stuff going through. But so again, it's people. I do see, and I respectfully disagree with this. Oh, that's just what you said. They come with pre-filters. What a stupid spot to put them, excuse my expression. And again, I repeat, they aren't good enough to take care of the return air from the room anyhow. The air coming in from outside, your makeup air, that's where you need to put good filtration. If you do that, you're good. So yes, do please remove the pre-filter.
Yeah, these air handling units are coming with typical pre-filters and post-filters, but they're all MERV, right? So the pre-filters are going to be MERV 8s. The primary filters are going to be MERV 13s. Now, keep in mind, a MERV is not a true HEPA. Bob knows that as well as anybody, and they're also not gasketed, right? So during heavy pollen season, and that's where we're at right now in the South is heavy pollen season. Those pre-filters need to be changed at least monthly because they're becoming impacted. Or if you're near an industrial site where you're catching a lot of that just heavy particulate. So it is one thing to manage here, but it's also good to manage at that at the ceiling level as well. And one thing I want to talk about filtration. So in an earlier version, I want to say it was maybe the draft copy or the second draft copy around 2014, 2015 of USP 800, it said that exhausted air must be HEPA filtered. Now that piece actually came out of the final 2019 document. I don't know why. I guess they just assumed that everybody in a powder handling situation would be attaching their powder hoods. So in theory, yes, all the HEPA filters in the hoods are picking up the particulates. Great. However, in my example, using that low wall exhaust grill to balance that space one time instead of the accordion of the powder hoods being connected, I would absolutely tell you to add HEPA filtration prior to exhaust, because there's an EPA guidance document, which actually may have passed by now, where they specifically call out testosterone going out into the water systems. Now, is it possible that a negligible amount of testosterone particulate could eventually find its way into the water system? Maybe, maybe not, right? It's up for debate. But one thing that I tell the pharmacies and the contractors is the issue that you never want to get into with a local building inspector or local EPA is it possible that you're ejecting any level of hormones out into the environment? The answer is no, you do not want to have that conversation. So to Bob's point, yes, we're filtering it here on the supply side, but I would highly recommend it, and it's not required, it is not a must, but I would recommend external filtration as well, so that we can say there are no hazardous drugs of any type, whether it's tretinoin for dermatology or whether it's methimazole for hyperthyroid cats, whatever it is. I would just say that this is a best practice.
We had a project, a look-at project. It had been done long ago from a very, could you put that back, please? The original.
Sure, yeah.
Oh, you're good. That just boggled our mind. But at any rate, you see where the supply is, and you see where where the hood is discharging, and it has to be a certain height in the air, which that appears to be. You also have to have it 20 feet away from the source. In other words, if you slid that hood down, that's not compliant. And it's happened. I mean, it was a major hospital, and they had done that. So do be aware that you do have to have there are local codes as far as biohazard stuff that you have to have spacing in there. Just throwing that in as in case you run into it, because unfortunately we did.
Bob, I'd like you to elaborate on the architects that you spoke to and their problems that they run into by designing a clean room or
well, an architect does not design what we're looking at right now. He traditionally goes out to an engineer. And even if you're talking about laboratory grade rooms, they are not sterile suites. And they make mistakes. I mean, or they really don't know, because it's such a small part of their business that they don't know the nuances that can get you in trouble. And that's where Brian and I have done a lot of this conversation, is trying to educate them to do it right. I guess that's all. I don't know how else to put it.
Yeah, and this is a prime example too. Typically, when I spec out in the drawing sets that I send to the architects, because I'm usually on the front end before architects and engineers, is I'll call out that any exit or emergency signage should be suspended from the ceiling, not mounted to the wall. This one got mounted to the wall. Now, they did come back, and at least they did caulk it, so I can clean that. I'm okay with that. But that got called on the punch list. So I guess what I'm trying to say is you got to think about the cleanability of everything. You know, how do you clean the exit signage? How do you clean the floor? How do you clean the hinges, the door sets? How do you clean the plumbing? And I've got just bukus of workflow example pictures that show kind of that is like, how do you clean these things?
Also, you do not want to be able, your plumbing, your sink should be at least 20 by 20 inches, because when you're cleaning yourself, you got to get your elbows in and so it has to be generous in size. You should not have to touch it. It should be automatic or foot plungers. I just want to throw that in.
And Bob, one of the things that you advised me at one time was this is exactly.
Yeah, that's what you don't do. How do you clean that? It's really common logic. How do you clean that? No, you may not put a computer in your sterile suite. Thank you.
Yeah, just throwing examples to try to keep the conversation going. So if anybody has questions, please feel free to.
Yeah,
this is a good example.
The most important part of this presentation is really to see what we don't know and we have to find out the bright people that do know. There's some
Yeah.
things, especially in this engineering, it's one of the biggest problems out there, and people get shell shocked when they find out that, you know, how much it costs and how much you need to make it compliant to the USP specs. So I think this was really to give you an overview, not to become engineers, but to look out for people that really know what they're doing before you start a project like this. As you can see, the intricacies are amazing. How much is valuable information that you should have. None of us will remember everything that's here because we're not engineers. However, you know, we need people that understand the HVAC systems and so forth.
I think we missed the most important part of all on sterile. The temperature must be 60 or 65 or less, and humidity must be under 60% RH. You do not buy a commercial office unit that can do that. You have to reheat the system at the very best to the air to drain out the amount of moisture. So there again is the cost. That is hugely expensive because it is not a standard unit. It has to be made up. I think that was really important to say.
Well, let me tell you what the money maker, money breaker statement is, and I'm surprised I left it out of my slideshow because I get into this all the time. So old technology of air handling systems are called single stage compressors. So your thermostat is sending the signal back to the compressor to start and stop on its cooling or whatever cycle. And humidity is only a byproduct of temperature control. It's not an independent variable. That's your single stage DX systems that are on all of your commercial spaces now. This technology is called what we call digital scroll or modulating, or simply called dual compressors. That means that I've got temperature and I've got humidity as independent variables being read independently with each other. And this computerized piece of equipment that I told you was $50,000 is deciding on how it's going to handle a temperature set point and a humidity set point. So if I were telling an engineer specifically how to design an air handler based on what we call the ASHRAE table, what we call psychrometrics, which is this chart, right? I don't expect you to remember any of this, but it's that they need to design, have a design target of 64 degrees Fahrenheit, which is if I'm wearing a rear tying, non-permeable gown, double shoe covers, double gloves, hair bouffant, and mask, I'm going to want it to be about 64, and I want it to always maintain at least 50% relative humidity. Now, where the engineers will fail is they say to you, well, we've done lots of clean rooms. We know about your 20C requirement. That's 68F. And we know that you should maintain below 60% relative humidity, so we're going to target. So they'll actually go to their equipment vendors and say, I need it to do 68F at 60% RH. Happens every single time. And what ultimately happens, the system fails because the system was not designed to go below those points. They designed it and engineered it to the lowest common denominator. I need to design it to what real life activity is. We have these things in rooms called BTUs. You and I, and process and depyrogenation ovens, we put off this heat all the time. So that's BTU, that's heat gain inside of a space. So you need to let the engineers know we're going to put a depyro oven in our ante room. We're going to have probably up to 4 technicians, 4 different hoods, and all this activity is happening inside of the clean room and or compounding spaces. And I need the target temperature to be 64F and maintain 50% RH. And they're going to look at you like you're crazy because that is truly the bottom end of a DX system. And this is still a DX system, but it has modulating or dual compressors. So this is the money maker, money breaker. You can buy an $18,000 single stage system, and in July and August, your clean room is going to fall out of specification. Or you spend $50,000 on a modulating dual compressor, reading temperature and humidity as independent variables, and you've got an uptime of 99% throughout the year in your clean room. And if your clean room's out of spec and people can't produce product, that is called a non-revenue generating activity. So yes, the price tag's going to hurt. But do you want your clean room to have a 99% uptime. So I would ask you to go back and look at all your temperature humidity logs for the past year and see what's really happening on certain times of the year. And I can tell you, June, July, August, September, you're losing control of your clean rooms because you're running a single stage DX compressor unit.
One quick note on that too, if you're doing, you will be doing variable testing, looking for viable testing. And if you go down, well, if you go down, you're out a month. It's about as simple as that. That's the best you can hope for.
Brian, I'd like to, get back to you on the size of the room and how, if folks are going to enlarge the room, or if the early stages, they're going to start to develop add a sterile clean room. So how do you anticipate your business to and this is a question for everybody, but how do you anticipate, if you want to enlarge, do you build a room bigger right at the get-go and say, you recognize certain amount of space that you can have, or add the cost of new, the equipment that can accommodate, extra hoods?
So I think there's a yes and a no answer to that. If you're designing a positive pressure clean room, you're going to do simple ear drops, eye drops, TPNs, those type things that are non-hazardous. And most, if not all of that air is actually then getting recirculated, whether it's an open plenum system or a direct duct system. So again, there's not a lot of energy impact on the positive side. On the negative side, right, and we talked a little bit about this with the biological safety cabinets, you can make the space too big. The bigger you make the space, the more air that's got to get pumped volumetrically out of the room, out of the building, and then volumetrically you've got to replace that. That's when it becomes an energy hog. So I would tell you to put some logic into it. You could design, let's say you got one biological safety cabinet, you go, is it possible I could grow to a second one? Yes. So instead of maybe a 6-footer next time, maybe I've already got a 6-footer, maybe I put in a 4-footer next time. And I allocated that much space during this design build. And so that the engineer understands what the future of my business may look like, but you just don't build it and hope they will come. I get this question a lot at conferences when I'm speaking. They say, hey, Brian, we're thinking about getting into sterile. I'm like, well, you don't get into sterile unless I have providers that are beating down my door for testosterone injectables and any other hormone, for women's health specialties, or again, a vet that's, begging me to do tacrolimus or something like that. If prescriptions are not sitting there waiting for me to do this, you don't get into sterile. Sterile is an expensive business to get into, to the tune of about, just for the build out, anywhere from $500 a square foot to $700 a square foot. I actually saw in California, it was $1,000 a square foot, but that's California. Let's throw that one out. But think about it, $500 a square foot to $700 a square foot on average to build a clean room, finished and done, all the mechanical, all the engineering. That doesn't really include the equipment that goes inside of it. Do you really want something that runs 24/7? You never lose control over a critical or controlled space, and it runs and it runs and it runs 24/7, and you're only using it on Tuesdays and Thursdays? No, it's not. You've got to strategically think about the size and the scope of what it is you're really getting into. Ernie, did that answer the question?
Yeah, for me, it did. I would answer for the other folks, but another question.
I was just going to add a little more. I'm sorry, Ernie, go ahead.
No, I want you to go ahead.
Well, I'm just going to add one more comment. Yeah, you can build a room anticipating adding more stuff 2 years down the road. And if it is a hazardous room, for the next 2 years, you're going to be just throwing a vast amount of money out because of the size. But the second thing is that picture, that equipment there, capable of handling it? Well, maybe not. Fan curves and all sorts of stuff come into it. So, but you can design it to be big enough to handle it in the future with a hot gas bypass thing to throw artificial heat in, which is horribly expensive. So you can do it. It's not a great idea, but as simple as that.
Hot gas bypass solenoid valve is only a band-aid. And the point of having a hot gas bypass is to keep the coils from freezing up. That tells me right off the bat that you designed the wrong system and you're trying to put a band-aid on it, which may be okay. But in the beginning, if this is a brand new project, I beg you to do a modulating or dual compressor system.
Oh, yes.
So So the room becomes, in your eyes, as both of you, Bob and Brian, the room is basically a piece of equipment when all is said and done.
The
Because
room is
that's-
a piece of equipment.
Yeah, it's functioning just as a piece of equipment. Absolutely. It's a living, breathing, air handling, pumping in, pumping out. It never stops. It goes 24/7. So it's probably the biggest expense if somebody's going to think about building a new pharmacy or expanding a pharmacy. The biggest financial lift of the whole project is going to be on the mechanical side, 100%.
Yep.
The mechanical equipment and ductwork will equal more than what the actual superstructure of the clean room is.
So we have 5 more minutes. I don't know, anyone else that might have some questions that be helpful to you to understand, potential systems or what you can expect if you want to renovate, or you get the opportunity now to ask these questions that might be helpful to you later on.
I thought of something just a moment ago. Is a simple thought. When you're looking for the potential site, make sure that the room, I don't care what floor it is, but make sure the next floor up is the roof. If you can.
I'm sorry, say that again, Bob. I think it.
Yeah, well, I'll put it a different way. If you put your clean room on floor 2 of 3, and then there's the roof, you've got to run that plumbing through a secondary space. It's just so much handier to have it up on as close to the roof as possible, whatever floor that may be.
That is a stellar point. I get pharmacies that call me. I look at the Google Street View, and one I got was, let's say, in Philadelphia. They're on level 1, and they've got 3 apartments or residentials above them. And I tell the pharmacy, I can't help you. I cannot help you become USP 800 compliant, knowing that there's residential apartments above your pharmacy. I'm not your guy. That's going to take somebody outside, because there's rarely ever a chase that I'm allowed to get into and get out of. And imagine running ductwork, because we've got to get that velocity exhaust off the roof. And it's just, it's very difficult. And even for hospital pharmacies, it's like, where do you put the pharmacy? Well, they're either in the basement or the first level, and then there's 6 levels of above them. That's when you've got to get the facilities engineer and many more engineers to come in and go, guys, how do we even put new mechanical equipment on the roof to run the supply down? Then I've got to run a return back up from my positive non-hazardous rooms, and I got to run an exhaust up. So I've got 3 new sets of ductwork that have got to go in a mechanical chase that's already crowded. And again, I can tell you every single time the chase is overcrowded. So if you're on the first level of a multi-story building and you need to become 800 compliant, or you're thinking about putting in a clean room, it's going to be difficult, if not impossible.
Good to rethink at the very least.
100%. Get on the top floor or build it on the roof. Just kidding.
So I guess there's no other questions, but can they get your contact information, both of you? If they have any further questions, will they okay with you if they think of questions later on? Oh, here's one. No, thanks for the valuable information. Oh,
You're
Marisol,
welcome.
I will say this here. ACA has allowed me to be moderator on some of these programs, and we're trying to get experts to continue the extension of their educational process. And they've been very, we're trying to get the experts to give you some information. And this is the time, it's, it's not a binding type of thing. And there's no credits to it, obviously, but to have experts like this that Bob and Brian on is invaluable, because it will help you at least make some decisions, because you never stop learning, no matter what we do and who we are. The learning curve just, certain things pop up that might say, hey, wait a second, I didn't think about that. And so ACA is trying to bring in different groups, and that's what we've been trying to do for the last wait a second, there's a question. You just validated our new central, I don't know, can you read that, Linda? That was a couple of questions just came up.
It says, you just validated our new central compounding service. We are on the right track for sure. And that was from Linda McElhiney.
That's good.
Oh, you're welcome.
Oh, that's great. It's great to hear. So anyways,
Brian.
I appreciate all of you taking the time to come on, and I hope this is good information. And if any, choose to use anything else that we can help, please don't hesitate to get in touch with any one of us.
Yeah.
Just
And I
so everybody knows, I'll be sure and I can send you the recording because the faculty meeting was recorded, and I will include the contact information for Ernie, Brian, and Bob.
Well, I am Ernie, so he owns me. Send it to him.
I wouldn't say that.
Well, sort of.
But these are informal, and I hope you like that type of presentation. It brings questions and whatever you wanted to know, and you're afraid to ask other people. This is the time to ask these type of questions. And we got more coming in the future. I think that we have a couple of more on the USP compounding areas coming up, and the next one, I think, is that the one, Linda?
I believe so.
Yeah. So anyways, thank you folks for allowing me to be part of this, and I appreciate ACA for letting me become a moderator. It's been a pleasure just to know and listen to some of these experts and be part of something like that is amazing. Thank you.
All right. Thank you, everybody. Have a great afternoon.
You as well.
Thank you, Linda and Ernie. Bye-bye.
Bye-bye.
Bye.